Good evening. I'm Parthashwati Das from MPSM 6 batch, and my today's subject of presentation is contribution of ballast water management system to reduce pollution at sea. If we would like to know about the ballast water, what the word means to us is an amount of fresh or salt water held in the ballast tanks of a ship. That can be a cargo ship, that can be a tanker, or any kind of vessel, which basically gives strength on the stability of the vessel and the maneuverability during its voyage at the deep sea. While the vessel is not carrying enough amount of cargo to maintain its stability, or not carrying any cargo, could be for the whole passage, and where stability is concerned and require the vessel to be stable with the ballast water during the rough sea passages. In today's presentation, if we have a look, what all will be the subjects that will be covering up are ship post ballast operation, the typical ballast system, its components, what is AIS and the ballast water convention, various treatment technology solutions, and some conclusion and recommendations. The shipboard ballast operations, if we look into the photo at the corner of the slide, this is a true example of what can happen when a ship loses its stability, and this can be resulted from the inappropriate operation of ballast water system as well. So with the ballast water, the ship maintains its seaworthiness, and when it is lightly loaded or maybe having no cargo on board, the ballast water also helps to maintain for the ships its draft, trim, stability, the bending moment, the shearing forces, slamming, propeller immersion, and numerous other helping facilities for the ship's sailing. The ballast system components consist of some simple liquid storage and handling system, the tanks, piping system, the vents and overflow system for the ballast, some sounding tables, some sounding pipes, and it is remotely operated. It also has some sea chest for the escape of the ballast or for the incoming of the ballast to the ship's tanks, and some overboard discharges. Next on this particular slide, we can have a general ideas about how a ship's ballast system is in. We can see in the light reddish areas on the photograph, which is denoted with the ship's cargo tank spaces, and surrounding them in light blue, we can see the ballast areas of the vessel. These are basically different tanks, which is having some sections with these lines that we have been identifying in the photograph. And on the aft, we have the ship's engine room areas and as well the ballast in the engine room. Now, we are concerned about the exchange of the ballast, and why we are concerned about that is basically about the AIS. And what are the AIS? These are aquatic invasive species, which are organisms transported by human activities to region where they don't belong to actually. And this is because of the history of the organisms that they are not belong to that part and are carried by our act. And by such sort of carrying, they became an inhabitant of the new place, which were not the original area of them for their living. Now, this is a question that how do they get here? There are many mechanisms actually which are capable of transporting AIS around the world. Here we can see the agriculture, live seafood shipments, the bait store trade, and international releases, which can be at times deliberate releases. Lastly, we see the commercial ships, which are basically responsible for up to 80% of the introductions in coastal habitats, which includes the ballast water and vessel fouling system. You can see in the photographs, the vessels are lying at the port. These are the vessels which are liable for bringing these AIs from some other places and releasing over here in these particular ports. What we have just talked earlier, now we can see the photograph representation of the same thing, that species, how they are introduced upon ballast water discharge in receipt regions. In the photograph on the top, we can see the vessel is loading ballast water when it is discharging her cargo, and this is to supplement the vessel's stability system. As we are discharging the cargo, we take in ballast, and we are surrounded by these aquatic species which are getting into the ship's tanks. You can see here the ballast tanks are surrounding the cargo tank areas, and they have been loaded into the tank. Now, the next stage is the ship makes a move from these places to that place, the bottom areas, and which can be some few thousand miles, can include a month-long sailing. And then finally, the ship will have to be loading the cargo in this particular port, where it will have to also discharge the ballast water, which is loaded in the last port. So we can see that cargo is being loaded here and the ballast is being discharged into the area just beside the port, or could be the area which is very adjacent to the port, wherever we have a loading cargo facilities. As the ship is fully loaded here, we see all the ballast areas are empty. So all the ballast water which was loaded into the ship's tank, also with the AIs, are released over in this water. So now, to prevent all these things, the Ballast Water Convention came. The convention sets the standard for ballast water management at some point in time. Ships using a ballast control device, which is basically the ballast water management system, must meet a performance standard, and which will ultimately reduce the transportation of unwanted aquatic organisms by a quantity of them in a quantity of water that is being carried out in the ship. Ships performing ballast water exchange system, they should have an exchange of 95% of the water that they contain. Ballast water control structures must be approved by management system in accordance with the guideline for approving ballast water management structures according to regulation D3 of the Ballast Water Management Convention. Now here we have tried to identify various systems of treatment technologies that we want to maintain on board a ship so that aquatic organisms transportations are reduced. The technology that is currently available or being developed typically can be divided into three categories on the primary method of incapacitating the organisms. These are mechanical, physical, and chemical. We have identified the three different areas. The D1 is ballast water exchange, which can be done by sequential method or flow-through method. What is the sequential method? Here, the ship's tanks are emptied in a sequence to maintain the vessel's stability, and finally obtain all the waters are exchanged. In the flow-through method, in the ship's tanks, the water is continuously charged in, so that with the pressurized water charge, the water inside the tanks goes out from the tanks, and finally we have exchanged the water with a new amount of water from the open sea, which is free of aquatic organisms. Ballast water exchange in D2. This is physical, mechanical, and chemical injection into the system. So the water will be free from these aquatic organisms. And then finally is ballast water isolations. This is another options which says about the reception facility discharge of the water or back to the origin, so that the aquatic organism transportation is restricted. Now, basically, all the ships in general will have to come to the standard of D2, the system of D2. So here with the D2, what is meant by D2? The D2 standard actually specifies the maximum amount of viable organisms that is allowed to be discharged, including a specified indicator microbes harmful to human health, so that it standardized the maximum number or maximum quantity of viable organisms that we are allowed to discharge. from the date of entry into force of the Ballast Water Management Convention, all ships must conform to at least the D1 standard, and all new ships will have to follow the D2 standards. Now, the solutions to this treatment technology have been identified over 3 different criteria, which is chemical biocides, which is active substances, chlorine and ozones, they are generated on board, and proprietary chemicals, some are delivered premixed from shore to the ship. Mechanical separations that we have discussed, these are obtained through filters, and physical change to ballast water environment, which is done by ultraviolet mild, cavitation, and deoxygenation. Now, the ballast water management conventions, how it will be implemented on the ships. Here we can see the implementation criteria for the new vessels, which are identified as the keel of the vessel, which will be laid after 8 September 2017, must install a ballast water management system upon its delivery. Existing vessels, which are identified as completing IOPP, which is the IOPP's renewal survey between 8 September 2014 and 7 September 2017, they must install the ballast water management system at the first IOPP renewal survey on or after 8 September of 2017. For other existing vessels, which are categorized as installing ballast water management system at whichever occurs first of the following criteria: the first IPP renewal survey on or after 8 September 2019, or second IPP renewal survey on or after 8 September 2017. Finally, we talk about the existing vessel, which are not required to have an IPP certificate, how they will be installing and performing the ballast water management system. They are categorized as tankers of not less than 150 gross tonnage and ships other than oil tanker of less than 400 gross tonnage. They will have to install the ballast water management system not later than 8 September 2024. Now, on the conclusion part of the ballast water management system, according to the conference's rule, all ships involved in global change must manage their ballast water. This has been confirmed, and including repressing it or treating it. Any of the system we will have to follow and ensure the aquatic organisms are not transported same way as before. So to do that, they will have to follow the standards which are categorized as D1, D2, or D3 standard. The D1 is the standards for ballast water exchange that require ships to exchange their ballast water in open waters, which is 200 nautical miles away on its passage from the nearest islands or nearest lands. And it has to be in the deep sea. The deep sea is categorized here as a sea which is having at least 200 meters of depth. D2 standard talks about a standard that prescribes the maximum number of living organisms that will be allowed to discharge in the ship's ballast system. Ships must install on board the ballast water management system to treat the ballast water before it is discharged. And D3, it is a standard for the approvals of ballast water management system to be used. In Canada, treatment system meeting the IMO ballast water management system code and approved by Transport Canada must be installed on board commercial ships of 400 GT or more, such as the bulk carrier, container ships, and oil tankers. So these are the 3 standards that we get an idea about on the implementation procedure of the ballast water management system. In fact, in general, later on, the D2 specifications will be in general followed by all of the ships. Typically, this entails installing unusual equipment on board the ship, and according to the procedure by IMO, countrywide government must accredit shipboard ballast water management system, and system must be put through both land-based and shore-based testing procedures, which is specifying the testing must be done on board the ship to comply with the system. As well, it is encouraged to do from the shore-based organizations. For instance, systems that use filters, ultraviolet high, or electrochlorination should be covered. Active material-based ballast water control system must go through a rigorous approval process and receive the IMO confirmation finally. With this, we complete the presentations for today, and I thank you very much, all of you, for attending this session. Thank you.